Yes. 71st question. The conductivity of the given compound in a solution corresponds to. So conductivity, that means when you added this in aqueous solution, so it will ionize as a Cl minus plus cobalt CoCl2 NH3 4 times with plus charge. So total how many ions? 1 plus 1, that equals 2. 2 ions or 2 moles of ions is the right answer. So next question is, the primary and secondary valency of complexes are. The primary and secondary valency of complexes. See here, if you calculate it, so there is a complex is missing here. So you write this complex Fe C2O4 thrice and 3 minus. So this is the given complex. We have to identify the primary and secondary valence electron. So primary valence electron means first we have to calculate the oxidation number. So X plus 3 minus 2, that equals minus 3. So X minus 6 equals minus 3. X equals, so plus 3 minus 6 will get plus 3. X equals plus 3. Now X equals plus 3 will be your primary valency. Secondary valency, now C2O4 is a having here how many molecules? 3 molecules. So we are going to multiply with bidentate ligand, so 3 2s are 6. So our answer is 3 and 6. Option B is the correct answer. So 2 coordinate, how many coordinate bonds we are going to observe? So for 1 C2O4, 1 coordinate bond. So for 3, 3 coordinate bonds. So 3 to the 6. So your correct answer is option B. 73. Which among the following is not a double salt? So mohair salt is a double salt, potash alum is a double salt, carnallite is a double salt. Potassium ferrocyanide is not a correct salt. So option D is the right answer. In complex compounds, the metal atom or ion act as a. So always remember the complex compound metal atom will act as a Lewis acid. Lewis acid means here electron acceptor. So it will accept the electron. So metal atom will act as a Lewis acid. So coordination number of the central atom or ion is determined by only by the number of pi bonds formed by the ligand with central atom ion? No. Both the number of sigma bond and pi bond formed by the ligand with central atom? No. Only the number of sigma bonds formed by the ligand with central atom? Yes. By the total number of electrons present in the ligand? No. So option C is the right answer. 76th question. The complex hexamine platinum 4 chloride will give number of ions on ionization. So hexamine platinum chloride. See here. So platinum hexamine NH3 6 with Cl4. Hexamine platinum chloride will give number of ions on ionization. So this will ionize as a 4Cl minus plus Pt NH3 6 with plus charge. So total how many ions? 4 plus 1, 5. So option A is the right answer. 77. Which of the following is true about metal in 3D series and EDTA complex? The ratio of moles of metal and EDTA complex is 1:6. No. The ratio of moles of metals and EDTA in complex is 6:1. No. 3D metal ion cannot be bonded with EDTA. No. The ratio of moles of metal and EDTA in complex is 1:1. So remember this. Moles of metals and EDTA in a complex is 1:1. Okay. So option D is the right answer. Now 78. Metal isothiocyanate is indicated by metal isothiocyanate indicated by option A. Okay. Now 79. A ligand which has two different donor atoms and either of two ligates with central metal atom ion in the complex is called ambidentate ligand. Remember this. So ambidentate ligand is the answer. 80. Ethylene diamine tetraacetate ion is an, so EDTA. EDTA is hexadentate ligand. Okay. 81st. Homoleptic complex from the following complexes is diamine chloridone nitro N platinum, triamine triaquachromium chloride, potassium trioxalato aluminate, pentaamine carbonato cobalto chloride. So which option is correct? For 81st, option C is the homoleptic complex. Only one complex should be there. Yes. Which of the following is not a chelating agent? So they are asking not a chelating agent. Oxalato, it is there. Glycinito is there. Ethane 1,2 diamine is there. Thiosulfate is not a chelating agent. Okay. Now 83. The correct IUPAC name of cisplatin is. The correct IUPAC name of cisplatin is diamine dichloridoplatinum 2. Diamine dichloridoplatinum 2. So I can write formula like this. So PTNH3 diamine dichloridoplatinum 2. Yes. Now 84th question. Which of the following is not a subdivision of structural isomerism? Structural isomerism. Geometrical isomerism is not a subdivision of structural isomerism. Yes. Square planar complexes of type MABXL, where ABXL are unidentate shows. Unidentate shows. See here. So it will form 2 cis and 1 trans. Remember this. 2 cis and 1 trans complex will be forming. Linkage isomerism arises in coordination compounds containing ambidentate ligand, unidentate ligand, bidentate ligand and chelate ligand. Ambidentate ligand. Yes. The incorrect statement about valency bond theory. Yes. Involves a number of assumptions. Gives quantitative interpretation of magnetic data. No. It is qualitative. Doesn't explain color. Correct. Gives quantitative interpretation of kinetic stability. No. So option 2 and 4 are incorrect. So option C is the right answer. 88. The type of isomerism arises from the interchange of ligands between cationic and anionic entities of different metal ions present in the complex is linkage isomerism, ionization isomerism, solvent isomerism, coordination isomerism. So interchange of ligands between cationic and anionic entities of different metal ions will take place in coordination isomerism. Identify the correct statement about crystal field theory. Okay. Crystal field theory. See statement 1. CFT is an electrostatic model. Correct. CFT considers ligands as a point dipoles for neutral molecules. Yes. So which option is correct? Both are correct. Option A is the right answer. 90. The degeneracy of d orbitals of isolated gaseous metals is maintained when negative charges of dipole surround the metal, spherically symmetrical field surrounds the metal, spherically unsymmetrical field surrounds the metal, non-spherical field surrounds the metal. So option B is the answer. Spherically symmetrical field surrounds the metal. So then degeneracy of d orbitals will take place. So 91st, the shape of pentacarbonyl iron with oxidation number 0. Shape of pentacarbonyl iron, that is TBP. Trigonal bipyramidal. Trigonal bipyramidal. So what is the hybridization of this? DsP3. So these are some examples which they gave in your NCERT. Yes. Number of bridged carbon carbon monoxide groups in octacarbonyl dicobalt. Octacarbonyl dicobalt. So dicobalt, octacarbonyl. So this is the formula. Now how we are going to write? See here. Cobalt. So 1 carbon monoxide, 2 carbon monoxide, 3 carbon monoxide, 1, 2, 3. So how many? 6, 7, 8. Now how many number of bridged carbon monoxides are there here? 2. So option A is the right answer. So the structure of tetracarbonyl nickel is, I think the same question is repeated. We'll move to next question. Match compound with metal. Yes. So we know that for chlorophyll it is magnesium. So 1C. So which option is correct? Option B. So directly you can write now. 2D blood iron. 3 Wilkinson catalyst rhodium. Vitamin B12 is cobalt. Yes. 96th. So these are the compounds and they give structures have A MM linkage, B terminal carbon monoxide, C bridging carbon monoxide, D zero oxidation state. Now Mn2 means obviously MM linkage will be there. Now B terminal carbonyl monoxide, terminal carbonyl monoxide. See here. Terminal carbon monoxide, so carbon monoxide 10 is there, here carbon monoxide 8 is there. If you write the structure, we'll observe this terminal carbonyl compounds. Yes. Then bridging is not available for carbon monoxide. Okay. Then zero oxidation state is correct. Option C is the right answer. 97. Complex ion formed when hypo dissolves AgBr in photography. So remember, option A is the right answer. AgS2O3 3 minus is the right answer. Wilkinson catalyst is used for hydrogenation of alkenes. So remember this. Number of bridging carbon monoxide ligands in Mn2CO10. Number of carbonyl compounds. So how many carbonyl compounds are there? Bridging 0. So Mn. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there is no carbon monoxide bridging, so 0. Option A is the right answer. Yes. 100. Statement 1. So both given compound are octahedral but differ in magnetism. Then see here, statement 2. For the first compound it is diamagnetic and second one is paramagnetic. So if you calculate the number of unpaired electrons for cobalt, and here you will get diamagnetic and paramagnetic based upon the behavior of the ligand. So both are true here. Okay. So now 101. Wavelength order of given compounds A, B, C and D. So A, B, C and D. So always remember, wavelength of the light is inversely proportional to crystal field splitting energy. Okay. Now crystal field splitting energy, how we will identify? Based upon strong ligand. So how we will identify strong ligand? Based upon this spectrochemical series. So based upon spectrochemical series, easily we can identify which one is strong ligand and which one is weak ligand. So if it is more CFC, then less wavelength. If it is more wavelength, then less crystal field splitting energy is required. Yes. Now which option is correct here? See, H2O is there, weak ligand, neutral ligand. Then you see ammonia is there. Then D, again water is there, then carbon. A cyanide is there. So for 101, which option is correct? Option A is the right answer. So BADC. So which is having less wavelength. So C for 101. How come ಇದಕ್ಕೆ ಇದು ಬರುತ್ತೆ? For 102, so which are paramagnetic? So they gave A, B, C, D, E compounds. So we have to identify the paramagnetic. So if you calculate the number of unpaired electrons for this nickel, you will get A and D as the answer. So you just try to calculate and you will get this answer. Okay. So this is direct question. 103. Correct order of observed wavelength. So we know that one relation, just now we discussed, it is inversely proportional to crystal field splitting, that is strong ligand. If strong ligand is there, then less wavelength. Remember like this. Now first you have to identify among this which one is strong ligand. So Cn is a strong ligand, that indicates it is having less wavelength. So among this, which option is correct? 103. See here, A and D we have. But between these two, we have to choose now. Again, so ammonia 3 times is there. Here chlorine is also there, weak ligand, then compared to ammonia. So COCl will be first coming, then cobalt with ammonia 6 times, then remaining carbons, cyanide, cobalt cyanide, hexacyanide. Okay. So option D is the right answer. So which system has maximum unpaired electrons in octahedral complex? Maximum unpaired electrons. D, high spin. So you will get maximum unpaired electrons. So wavelength of the given compound 1 and 2. See here, now between water and this En, which one is strong ligand? En is a strong ligand. Then it should have less wavelength. So among this, which pair is having less in second option? C. Option C is the right answer. True statements about cobalt hexafluoride. See, Now, octahedral carbon coordination number is 3, oxidation number is +6, sp3d2 high spin. So these are the information which was given regarding the given compound. So now check for this coordination number and oxidation state. This is both are not correct. So octahedral is correct, sp3d2 is correct, high spin is correct. So option D is the right answer. So which statements are true about NiCl4 2-? So A tetrahedral, B coordination number equals 2, oxidation number is +4, sp3 and D high spin and paramagnetic. For 107, so you will get A, C, D, E. So here also coordination number and oxidation number is wrong. So match the following. So just you have to match the compound with wavelength. So we know that if it is strong ligand, then less wavelength. So for 4 it is B. So for it is B. Now second and third B and C we have. Again now between these two we have to check now. For first one you see, first one ammonia is there 535. So this is the weakest ligand, then for that highest wavelength 535 is the highest wavelength. So option C is the right answer. For second one C, for third one A, and fourth one D. Okay, so option C is the right answer. So relation between crystal field splitting and octahedral and tetrahedral complexes. So always remember, don't get confused, delta T equals 4/9 delta naught, not delta naught equals 4/9 delta T. So option A is the right answer. So 110, adding En to the given compound, the correct order of color changes 1:1, 2:1 and 3:1. So this is given in your NCET table. So based upon that, we are going to choose the answer green, pale blue and violet. So this information I will just post in the comment, or I will send the PDF link so that you can see this table. So in text question, okay. So you will get green, pale blue and violet. So 111. So delta 0 or octahedral is less than P. The configuration of D4 is. So configuration of D4 is T2G4 and EG0. So this is the right answer. Now correct increasing order of ligand field strength. So spectrochemical series. So if you see, easily you can identify, so I minus, then Cl minus, then H2O, OH minus and carbon monoxide. So option C is the right answer. 113. Octahedral complexes Ml6N plus, Mn plus has 5d electrons and L is strong field ligand, unpaired electrons we have to calculate. So how many unpaired electrons present here? One unpaired electron present. Octahedral complex Ml6N plus and Mn plus have 5d electrons. If it is strong ligand is present, then that 1, 2, 3, 4, 5. So if strong ligand is present, then these two electrons will shift and it will pair, and finally we will get one unpaired electrons. Yes. Now, so if octahedral splitting is less than or greater less than P, the correct electronic configuration of D4 system will be, D4 system will be, see here, again the same question they repeated, T2Z4 and EG0. The same question in different form they asked. So in an octahedral crystal field, the T2Z orbitals are So if you remember the diagram, so it will be lowered by 0.4 delta naught. So it is lowered by 0.4 delta naught. The correct electronic configuration of D4 in a weak ligand is, so they are asking weak ligand. So weak ligand means here T2G1 E3G. So option D is the correct answer. So correct electronic configuration of D4 in a weak ligand is, so they are asking weak ligand, then remember, so weak ligand means, so easily you can identify T2G3 and EG1. Option A is the right answer. So remaining option is not suitable for that. According to spectrochemical series, the strongest field ligand is among the following: carbon monoxide. Yes. 118. Arrange in increasing order of crystal field splitting. Crystal field splitting. So we know that more the strongest ligand, then more the crystal field splitting energy is required. So among these four, which of the following has having strongest ligand? Cn. So then option A is the right answer. In a complex with secondary valency 6, the set of d orbitals which experience more repulsion. So more repulsion means dx square minus y square and dz square. So these two orbitals will experience more repulsion. For the given compounds, so for option A, inner orbital and outer orbital complexes are respectively both inner orbital complexes. So option C, outer orbital and inner orbital complexes respectively, both outer orbital complexes. Option C is the right answer, outer orbital and inner orbital complexes respectively. 121. Complex with maximum magnetic moment. So maximum magnetic moment means here more number of unpaired electrons we have to identify. Now which option is correct? Option C. So because fluorine is weak ligand, because of that more number of unpaired electrons will be present. So easily you can identify. So square complex is NiCN4 2 minus. Okay. Then tetrahedral complex is weak ligand NiCl4 2 minus. So this is square planar, this is tetrahedral. The high spin complex is option D is the right answer. Why it is option D? Because splitting will happen because of weak ligand, here less splitting will happen. So high spin complex. So 150 question, 125th and the last question, the inner orbital complex is option A is the right answer, inner orbital complex. So if you observe all the options, option A is the right answer. So these are the questions or the MCQs which we discussed or you are going to practice for your board examination. So for any queries or for if you want any specific topic to do in the chemistry or any other subject, so please comment below. We'll meet in the next session. Thank you.